This video is about simplifying variable expressions. Before we simplify variable expressions, we need to make sure we have a clear understanding of the vocabulary. Let's start with the word term. The term is the parts of the expression that are added together. Let's look at our variable expression here. We have a set of terms that are being added together. 9x is a term, 3, 7x, and 5 are all terms because they're the parts of the expression that are being added together. Our next vocabulary word is coefficient. A coefficient of a term with a variable is the number part of the term. Alright, so only terms that have variables like 9x and 7x have coefficients. The coefficient is specifically the number part of the term. Remember, we talked about each of these things being a term. So 9x is a term, 7x is a term, and they both have coefficients which are 9 and 7. So 9 and 7 are coefficients. Our terms were 9x, 3, 7x, and 5. A constant is a term. Notice how a coefficient is part of a term, where a constant is a term. A constant is a term that has no variable. And we have a few of them in this expression, 3 and 5. Notice 3 and 5 don't have any variables, and that's what makes them constants. The last term here is like terms. These are terms that have identical variable parts. If you look at this specific expression, 9x and 7x have identical variable parts. We could basically say the same thing about 3 and 5 because they don't have a variable. They would also be considered like terms. So if I were to list my like terms, I would say that 9x and 7x are like terms, and 3 and 5 are like terms for this specific expression. Now, a mathematical sentence using variables, numbers, and operations is what an expression is. So this here is what we're calling an expression. An equation is the same thing but includes an equal sign. So it might be equals 20 would make this an equation versus an expression. An expression doesn't have an equal sign, an equation does. One way to remember that is to see the word equal in equation. The solution of an equation is an answer to what a variable could be. So for instance, if I said x equals 5, that would be a solution to this specific expression or equation. Solving an equation is finding the solutions of the equation, or finding out what x would equal. So let's apply all this. Let's say I have the following expression. Negative 19 minus 11a plus a plus 16. Now, if you notice up here, it says terms are parts of the expression that are added together. Well, we have a principle that helps us deal with this. We can DPS this expression. So I'm going to add the opposite here, and now I have all addition signs, and I can identify my terms. My terms for this specific expression are negative 19, negative 11a, a, and 16. Now, Let's identify what would be our coefficients. Remember, coefficients are the numbers that go with our terms that have variables. Well, we have two terms with variables, and so our coefficients for this particular expression would be negative 11. Notice I'm including the negative sign. And then we have this one here. Well, this is like 1a, so I'm going to use the number 1 for that one. So those are my coefficients. Now my constants, which are numbers with no variables, they're terms. We have two of those as well. This has no variable and this has no variable. So negative 19 is a constant and 16 is also a constant. So now I've identified my terms, my coefficients, and my constants. It should be pretty easy now to identify what are like terms in my expression. Well, negative 19 and 16 have similar variable parts, as well as negative 11a and 1a. So these would be considered my like terms. Now let's rewrite our expression and simplify it. Keep in mind that I can only add like terms. I cannot add terms that are not like. So I use what are called hookup lines to show my like terms. So here I've connected my like terms. Remember, they're connected with an addition sign. So negative 19 plus 16 would give me negative 3. Because one's negative, one's positive. Now here I have negative 11 A's and 1A. Think of it this way. I owe 11 apples and I have 1 apple. That means that I still owe 10 apples. So it would be negative 10A. So use the coefficients to calculate. Let's look at another example. Let's say I have 4x plus 2x. Well, let's pretend x stands for xylophone. So I have 4 xylophones plus 2 xylophones. These are like terms. I can hook them up. If I add the coefficients, I get 6. And I now have 6 xylophones. So that would be my expression simplified. Here's another example. Let's say I have 9c squared minus 4c squared plus 2c squared. First step in solving this expression, or simplifying this expression, is to DPS it. So turn it into an addition problem. Now, notice they all have the same variable parts. So I can add all of these terms together. Let's start with 9c squared and negative 4c squared. I'm going to add my coefficients, which gives me 5c squared plus 2c squared, or 7c squared. Notice how I worked down the page and I added only 2 terms at a time. Here's a what if. What if this expression would have been 9c squared plus 4c squared plus 2c? How would this be different? Well, c and c squared are not the same variable parts. So in this expression, I can only add the like terms 9c squared and 4c squared. 9c squared and 4c squared would give me 13c squared plus 2c, and this would be as simplified as I could make this particular expression. Now let's do one that's a little bit more complicated. Let's say I have negative 2 times 2m minus 1 plus 4m. And I want to simplify this variable expression. Well, notice I don't have all addition here, so I need to fix this first. I'm going to add the opposite here, so I DPS'd it. Now also notice that I have multiplication here. This is not just an addition problem. Well, I can use the distributive principle and make it negative 2 times 2m plus negative 2 times negative 1 plus 4m. So I just used the left distributive principle of multiplication across addition. Now, I can multiply these two. So negative 2 times 2 is negative 4m plus a negative times a negative is a positive, so I get 2 plus 4m. Now, notice I now have all addition signs. I have one set of like terms. My coefficients of my terms are opposites. This means that I now have 0 m's plus 2. Well, we know that 0 times any number gives you 0, so I'm left with 2. So that's this particular expression simplified. Notice I use the introductive principle of opposites, and I also use the principle for multiplying by 0. Let's try another one of these expressions. Let's say I have p minus 5 times 2 minus 3p plus 1. First step, turn everything into addition. So I'm going to add the opposite, or DPS, my expression. Now, I have addition sign here, and then I have this multiplication problem here. I have to do that before I can add anything. So I'm going to distribute my 5 across here because I can't add this when there's a variable here. They're not like terms. So I'm going to take p plus negative 5 times, in parentheses, 2 plus negative 3p plus 1. This will give me p plus negative 5 times 2 plus negative 5 times negative 3p plus 1. P plus a negative and a positive make a negative, so negative 10 plus 2 negatives make a positive, so 15p plus 1. Now I've got an expression that I can simplify because I have all addition and I have some like terms. So here I have two terms with the same variable. Remember, when there's not a number in front of it, you can assume it's a 1. So I have 1p plus 15p's, which would give me 16p's. Then I also have these two like terms, which are constants. Negative 10 plus 1, I have a negative and a positive, and I would end up with negative 9 because 10 was a larger number. So this is this expression simplified. This is the end of the video on simplifying variable expressions.